This presentation is going to use 3ds Max to produce an assembly sequence from another design model. Let's take a look at the agenda. I'm going to use an AutoCAD model for the example today. In particular, this model will be coming from Advanced Steel. There are a couple of things I'd like to point out that could be relevant if you are using Advanced Steel. It is very similar to how we would bring a model in if it were from AutoCAD. There are some subtleties though. After I bring in the model, I'll show you a way to quickly update the materials. Next, I'll show you a quick way to set up the scene to focus on just the components that will be part of the animation. Then I'll apply motion to those components to illustrate the assembly sequence. After that, I'll show you how to get the animation ready for production. This will involve looking at the final appearance and making sure it looks the way that we need it to. Once we're happy with the overall scene, I'll show you how to create the video file, which you'll be able to share with the shop floor or whoever would benefit from it. All right, let's get our model brought into 3ds Max. I've got a scene started here. There's not much to it. The settings I'm going to be using here are going to be as out of box as possible. To bring in our model, I'm going to go to the File menu and down to Import, and then I'll choose my option here. So for an Advanced Steel model, I'm going to use Link AutoCAD. And then I'll just go to my Advanced Steel folder, wherever that project happens to reside. We don't have to do anything to the Advanced Steel model in order to bring it into Max. So I'm just going to link it in. The Manage Links dialog appears. We're going to take a look at a couple things before we attach this model. First, I did make myself a preset just for Advanced Steel. You can see it listed here, and I want to show you what I did there before we bring in the file. So I'm going to go over to the Presets tab first and look at the Advanced Steel preset that I made. And this is pretty straightforward. What I'm focused on is what I'm going to bring in from that file. So I'm looking at the Include section, and this is on the Basic tab of the preset. And I've cleared all of the checkboxes. So for today's example, we don't need to bring in all the extras, right? So in Advanced Steel, we usually don't deal with cameras as far as animation goes anyway. We don't deal with sun and sky. We don't deal with lights. So there's no reason to check any of these boxes, which are normally checked in the other presets. The only one that you might use if you're working with Advanced Steel might be external references. Again, I'm not doing that for today, so I just cleared everything. On the Advanced tab, there's one critical setting, and that's the Derived setting. The one I'm using today is Entity Blocks as Node Hierarchy. After some testing and some trial and error, I found that this is a very good hybrid of what we're going to want to do since we're going to be animating. This particular setting is going to allow us to still control visibility by layer, as well as give you individual control over each part when the time comes. I've got two other options checked here, and these are optional. I went ahead and checked them just to illustrate that since we are going to be updating the materials in Max, this will help preserve those changes if I happen to go back to Advanced Steel, make a change, and then I want to reload the file that we're linking. This would prevent my changes in Max from being overwritten. Again, those are optional settings, and you can play with these later on to see how they work for you. Okay, so now that I have the preset, I will choose it back on the Attach tab, and then I'm going to select Layers to Include. In Advanced Steel, there are a handful of layers that are important to Advanced Steel. They have objects on them, but they're not 3D solids. So we're going to choose what we're going to bring in and leave the excess behind. So I'm going to choose select from list here, and then I'll proceed to deselect all of the layers that aren't going to be important to the animation. And they're going to be all the ones that have options like the connection boxes, the connection frames, things that aren't solid. But as an example, I also wanted to show you that if you just wanted to bring in one of the sub-assemblies that's in your advanced steel model, you could do that too. So as a quick example, I'm just going to hit none. I'm going to deselect all layers, and I'm going to pretend that all I want from that model is the ladders. So I'm just going to include the one layer and go ahead and attach it. So as you can see now, all I got from that model is everything that's on the ladders layer. So this could really cut down on your setup time by leaving behind everything that doesn't matter regarding your assembly sequence. Now, the rest of the presentation, I have another model ready to use. I just wanted to illustrate that you could bring in single objects or single sub-assemblies based on their layer. So I'm just going to hit undo and show you what I normally would do for an advanced steel model. So I'm going to go back to File, Import, and link AutoCAD. There's the advanced steel model, and we're back where we were. I'll select layers to include again and select from list. This time I'm just going to deselect the non-solid layers. Those would be layers like construction lines, layer 0, your camera's layer. And we'll just keep stepping down here. Here's some more. Connection boxes, connection frames, and def points. Max does not need layers like that. Max also does not need the grids layer, height notations, or hidden grids. The nodes layer can be excluded. And then the bottom two, welds and working planes. So this will bring in the complete model and leave behind all of the accessory layers that we're used to using in advanced steel. So okay there. And then I would click attach this file. Now I'm not going to click on attach this file right now because it will take a couple of minutes for Max to bring this file in. I've prepared this ahead of time, so I'm just going to switch to that to save us that load time. When I clicked attach this file right before the webcast started, it took a couple of minutes to process, and then this is what came in. So the model is there. The appearance leaves something to be desired since everything is black. We will address that in a few moments. But here is the model from Advanced Steel. Over in the Scene Explorer, you'll see the layers that were created by Advanced Steel. And if you're in Max and you don't happen to see layers, come down to the bottom of the Scene Explorer and click on Sort by Layer. And you'll see something similar to this. There might be some arrows next to each layer, and if you expand on those, you'll see the objects that are on each layer. There's also an eyeball, so we can work with the visibility of any of these layers, just like we would in AutoCAD, and start hiding things. This is what that preset did for us. But if I need to, I can also select something out on screen and hide it individually with the Hide Selection tool. So we've got layer control and we've got object control at the same time. All right, I am going to bring that element back, so I'm just going to do an unhide all. And there you go. So once we link in our model, The next step will be to work on our appearance and get our view angle set how we want to see our animation. But first, I would like to review what we just did. Looking at the preset again, just remember on your basic tab of your preset, and I do recommend creating a preset for advanced steel models. You might have another preset for regular AutoCAD models. You might have a preset for Revit, etc. So for advanced steel, on the basic tab, review the include options. What do you want to include when you link in the file or exclude? On the advanced tab, to get the control that I mentioned, once it's in Max, use the Entity Blocks as Node hierarchy, derive setting, and then on an as needed basis, the other checkboxes are options. I'm just showing you my preferences. I do like to preserve material changes in Max, and that's why I've got the bottom two options checked here. Before you complete the link, make sure you select layers to include and go after the geometry layers only. Exclude everything else. After you attach, your geometry might come in all black. That's expected. Or it might come in all white or all gray. Point is, it will come in all the same because we don't normally assign materials to our 3D solids in products like Advanced Steel or AutoCAD, and that's okay. Now, that's going to be part of this workflow. We'll look at that next. Okay, so let's get back in our model and we'll set up our view angle and update the materials. So we're going to do a small animation. It's going to be of one of the clip angle assemblies. So there's a lot of layers here that we can just turn off. The layers that we're going to need are going to be beams, bolts, clip angles, and columns. All the other layers, I'm just going to select the eyeball and turn those layers off. So this is a very quick way to do a bulk visibility setup. Now we're not done yet. There's still a lot of elements on screen that aren't going to be part of the animation. So then I'm just going to orbit around and find the view angle that I want. And I decided to do this clip angle assembly that's down here. So I'm going to orbit to something like that to get started. Next, there are still some elements visible on screen that aren't going to be relevant. So I'm going to further hide at the object level. And I'm going to do that by selecting right around where I'm focused, which is going to be this area right in here. So everything else I would like to hide. So I'm going to select what I'm interested in. And I'm going to right mouse and hide unselected. This is Max's language for isolate. So now I'm down to just what's important to the animation. And that's how we'll take care of the visibility setup. We'll orient the model how we would like to see it, and then hide everything else. Next, we'll deal with the black. Max is known for its ability to show things with realistic materials, and we want to make sure that that's part of our assembly. So I'm going to turn on the material browser next. And actually, before I do that, I do want to review real quick what we just did to get the view itself ready. All right, so first, just choose your orientation. That can be done along the way. We'll settle on a final position toward the end. You're going to want to hide the unwanted components. Just make sure you rely on the layer list in the Scene Explorer to help you do it quickly. All right, And then to do the appearance, I'm going to start with the art renderer. So let me explain that. The art renderer is the default rendering engine in Max. When you start a blank file, if you've never made any changes, that's what will be set in the background. To look at that setting, you would click on Render Setup, which is right here in the main toolbar. And there's the setting for it. It's called the Art Renderer. That's what gives things the realistic appearance. And that's what we're going to start with. So if you've never changed anything regarding rendering, then that will be the out-of-box setting. Next, let's look at the material editor. And that setting is right next to the render setup. We're going to be using the Slate material editor today. So we're just going to have this open along with what's out in our scene. I'm just going to push this over to the side and have the material dialog open along the way. Now, normally, I would take the material editor and set it on my second monitor. I want you to be able to see what I'm doing in here, so I'm going to be moving this around a little bit here. And then I'm going to get started updating the materials. So I'm just going to set the material editor out in the middle for a moment. Over in the Scene Explorer, I'm going to select my beams layer and the columns layer. And then I'm going to select children, which is right here. Now, if you're looking at Max and you don't see this button, what you'll want to do is stretch your Scene Explorer out a little bit. You'll notice that there are additional buttons that are there. We want to make sure that we can see the Select Children button. So I just stretch the Scene Explorer, so that's the last button visible. That still gives me plenty of room in the scene. So with the beams and the columns layer selected, I'll click Select Children, and that will highlight all of those elements in the scene. Next, I'm going to open up the material editor, and I'm going to go to the Autodesk Material Library, which is right here. This is available because we're using the Art Renderer at the moment. And there's plenty of choices, and they're all realistic. So I can now go down by category. I'm going under metal and then steel, and I'll choose a material for the beams and the columns. The one I'm going to use today is the oxidized material. What you'll do is just drag that out into the middle area here, which is called the canvas. There's the material. Our objects are already highlighted. So what we'll do on the canvas is right-click on the material and assign material to selection. And that takes care of the beams and the columns. We're going to repeat that for the rest of the components that are going to be part of the animation. Once you assign a material, what you'll want to do back on the canvas in the material editor is just window select the entire material and delete it. That'll remove it from the canvas, and we're just going to work with one material at a time. Makes it easier to see when we do it this way. The next, the clip angles are still black, so I'll do the clip angles next. So again, I'll select the clip angles layer, and again, select children, and that will highlight the clip angles. There we go. So again, you select your layer, and then you'll select children, and that selects the objects out in the scene for you. Back in the material editor, we'll select another material. For the clip angles, I've decided to use the plate material. So I'm going to drag that out to the canvas and right-click on the material, assign material to selection. That takes care of the clip angles. To finish up this material, we'll window select it back on the canvas and delete it. That gets us ready for the next component, which in this case is the bolts. So I'll select the bolts layer. One last time, select children. And now the bolts are selected in scene. And this avoids having to cherry pick the individual objects. With the bolts selected, now we'll go back to the material editor one last time and choose a material. This time I'm going to use the galvanized material, and I'll drag and drop that from the library over to the canvas. Then right-click that material, assign material to selection. Then window select that material and delete it to clear the canvas. And that's all we need to do in the material editor. We have steel for the beam and the columns, and we have the plate material for the clip angles and the galvanized material for all the bolts. And to finish up our visibility settings here, do a little bit of orienting. And anytime you need to control your ground point when you're moving around your scene, you can select an element, and that becomes the center of rotation as you are orbiting. We're going to focus on the assembly for just this clip angle right in here. So I'm going to do some final hiding of the elements over here. So I'll select the beam and do hide selection. That'll take out the beam. And then I'll do the same thing for the rest of the components on the back side here. And this part is usually on a case-by-case basis. You'll do as much hiding or isolating as you need to. And once you do that, you'll start to see some wireframe objects. These are also coming from Advanced Steel. They will not have an effect on the assembly sequence, but they are visible. And if that is a nuisance to you, you can hide those as well. Just be careful that you're only selecting those wireframe elements. So I'll do a little bit more just to get those off screen. They're embedded in your beams because when we apply holes, then there are some wireframe objects that represent the holes. Max recognizes those, but we can hide those separately from the beams itself. So if that is a concern to you, then you can continue hiding until you're down to strictly the 3D solid objects. So again, there's a few more here. I'll go ahead and select those and do one last hide selection there. They don't have to be hidden. They will not be rendered when the time comes. But if you don't like looking at things like that, then feel free to hide those as well. So this is what we want to focus on, is just the components involved in the animation. Okay, so let's review the material sequence here one last time. Again, we did start with the art renderer, which is the default. It's very easy to apply materials to get started. We select our components, and here's the workflow, the steps that we used. We select the layer first, then select children, which actually selects the objects in the scene. We choose a material and add it to the canvas. Right-click the material and assign to selection. And then remove the material from the canvas. And we repeat that for all the components that need a material. At this point, we're ready to put the assembly in motion. So back in our Max file, I'm just going to zoom back a little bit. You don't want to back up too far, but you also don't want to be too close. So something like this will be ideal for this assembly. And we're going to start by pulling this apart. So think of it in reverse order. So we're actually going to disassemble it first. And when we're finished, we'll reverse the sequence so it looks like it's an assembly versus a disassembly. And we're going to be working with the timeline, which is down at the bottom of your screen, where all the numbers are located. There's also a slider bar right above the timeline, and this is how we're going to play back our assembly. The timeliner does have some marks on it. Each individual mark represents one frame in time. So if you look at the default timeline right now, there are 100 frames. And we'll adjust that as we need to later on. There's nothing on the timeline yet since we haven't actually moved anything. And whenever you start animating, the first thing you're going to want to do is turn on Auto Key. That's going to turn your timeline red, and that represents the recorder, right? So when Auto Key is on, we are now in record mode. Anything that we move is going to be captured by Auto Key. So I'm going to do that first. Next, I'm going to move the slider bar right here out to where I would like my first move to end. So for this example, I'll just pull it out to frame 15. And then I'm going to select the first set of bolts that I'd like to disassemble. And I'm going to choose the Select and Move tool from the menu. That puts me into the Move command, at which point you'll see your gizmo, and we could use that to drag and move those bolts to a new position. And once you do that, move the slider bar out just a little bit, you'll see that there's two red boxes on the timeline now. The first red box represents the beginning of your move. The second red box represents the end of that particular move. And as I move the slider bar, we can test that. The first set of bolts takes 15 frames to complete its move. Now it is starting to move right away. So if we were to play this back at full speed, those bolts are moving from the very beginning. If you want to add a little pause at the beginning, you can do that just by dragging these keys along the timeline. So I can take the key that's at 0 and drag it to a new frame. So I'll move it out to frame 5. And what that's going to do is add a little pause right at the beginning, and then the bolts will move, and then they'll stop at frame 15. And that sequence right there, we just repeat for each component that we need to move. So I'll go to the next one. I'm going to continue with having a pause in between. For each move, we'll add a pause of 5 frames. So that means the first bolts will stop at frame 15. We'll have a pause between 15 and 20, which means our next move should finish at, say, frame 30. So I'm going to set the slider bar at frame 30, and then we'll move the next part. I'll move the beam next. And I can't see the gizmo for the beam, so I will need to zoom out for a moment. There's the gizmo. Now I can drag the beam. I'll pull it back this way just a little bit. And now the beam is in motion. But notice that the beam is still moving from the very beginning. So it's actually moving before the bolts are moving. And that's because its first key or start key is still sitting at frame 0. So each time we do this, we have to remember to move the 0 key to its actual start frame. In this case, it would be at frame 20. So now we've got a pause. Then the bolts move for 10 frames. Then there's another pause. And then the beam moves for 10 frames. And then we'll just repeat this for each part. We're at our last move here, which is at frame 30. We'll pause between 30 and 35. And I'll go out another 10 frames to 45 and move the next component. So it'll be these bolts here. So I'll move these to their final destination, something like that. And then I'll go to the timeline and drag its 0 key to its true start point, which would be right there. And then use the slider bar to play back. And the reason I'm doing this with the slider bar is just so we can test. It's not full speed. I can drag the slider bar as fast or as slow as I want right now, just to get the initial sequence in the right order. So now we're out at frame 45. I'll include another pause from 45 to 50, and then add 10 more frames. Then I'll move one of the clip angles. It comes up to about here, and have it float out this way a little bit. Then move its 0 key up to 50. So a 5-frame pause, 10 frames of movement, and then another 5-frame pause, and then 10 frames of movement is the pattern that I'm using at the moment. So this clip angle ends at frame 60. So our next pause would be to 65, and then another 10 frames. Another set of bolts in the back here, so we'll pull these out. And you can use the gizmo and move as much as you want. AutoKey's just going to extrapolate point A and point B. So we'll set it to about right there, and then move its 0 key out to there, and then slider bar to test. Looks good. Another pause. About 10 more frames for the final move, which would be the last clip angle here. So something like that. Just don't forget to move the key that sits at 0, otherwise it starts moving and it's moving the entire sequence. That's an easy step to forget. Once you make your last move, you can continue using the slider bar to play it back. We could use the playback tools and watch it full speed. So I'm going to use that to bring it back to the beginning and then play it and see what we got. And the timeline will repeat automatically until we stop it. So there's our initial sequence. We'll stop any time, and we can reset it back to 0 there, or we could use the reverse or forward tools as we need to. Also done recording, so now is a good time to turn off auto key. There's our initial sequence. And let's review what we just did. Before starting any animation, just remember to make sure you turn on auto key. And I also did mention in the beginning, we want to make sure that another tool is turned on underneath your timeline. There's a little extra bar underneath. It's very subtle. And you can see if that's there just by clicking on your timeline to highlight it. And make sure you see this darker gray bar underneath. If you don't see that gray bar, what you'll want to do is right-click on your timeline, go to Configure, and Show Selection Range. This can be done at any time, so if you haven't done it by now, no worries. We can turn it on now or later. Mine was already on, but I want to point out where that setting is. Okay, so when we're setting up our assembly sequence, we're actually disassembling first. And before we move any of our components, make sure you turn on auto key. And then you'll start with your last component. You'll move it. You'll set the slider bar at the frame where you want that move to be finished. And then you'll move the 0 key to the start frame that you want. And in this example, I went with 10 frames per move and then a 5-frame pause in between. And you'll repeat that sequence for each component. Next, we're going to reverse this sequence so that it becomes an assembly sequence. And here's how we're going to do that. Go ahead and move the slider bar back to the beginning. I'm going to go down below the timeline to time configuration. What I'm going to do is increase the end time. We've pretty much used up all of the available frames. We're up to about frame 90 at the moment. We've only got 100 frames total. So we're going to double the number of frames. I'm doing that just by changing the end time. That gives me more frames to work with. Then I'm going to select all of the parts involved. And you'll see their keys down on the timeline. So there's some red keys, there's some white keys at the moment. But notice that the last key is still at frame 90, which is where we ended. So if I were to play this back now, it still looks like it did before, but there's a huge amount of dead space now because of the additional 100 frames that have been added. So we have some room to work with now. So we're going to keep all of the objects selected. On the timeline, I'm going to drag from the right to the left and highlight all of the keys. And these keys can be manipulated separate from the objects out on screen. So with all of the keys selected, this is where being able to see that slider bar underneath is important. We can drag the key that's on the left as a group and notice that it either squeezes or stretches the distance between the keys. So it's maintaining that relationship. I'm going to take the bar that's on the left and drag it all the way out to frame 180. So we ended up with 90 frames being used. So I'm going to maintain that interval just by stretching from 90 to 180, but I'm doing it all the way from the left. Now if we play it back, there's going to be a gap at the beginning or some dead space, and then it's going to start, but it's going to be an assembly now. Fix the dead space that is now at the front of your animation. What you can do is now select in the middle of this black bar. That's the selection range that I mentioned. When you select in the middle of the bar, you can move the entire bar as a group, and I'll just move it back so that the first key is again at frame 5. So I still have that short pause at the beginning. But now that it's reversed, it is an assembly sequence. It is moving kind of fast though. Each part's not in motion for very long, and there's a lot of dead space at the end. So to fix that, as long as all your keys are still highlighted, now we can stretch from the right and extend the sequence. So instead of ending at frame 90, let's stretch it out and I'll have it end closer to the end of the timeline, say to 180. Now when we play it back, there's a lot more time in between each move. Each move takes a little longer and it looks a little smoother now. There's a little bit of pause at the end. And if we need more pause or less pause, we would just increase or decrease the total frames in the time configuration. I'm happy with what I'm seeing here, so no need to make any more adjustments to the frames. And that will complete the assembly sequence. Okay, let's review that portion. Again, we moved each component. We set the slider bar where we want it to finish and adjust the 0 key for each of those components to its actual start frame. To reverse the sequence itself, the first thing you'll do is edit the time configuration and double your end time. So if you started with 100 frames, give yourself 200 frames. If you started with 200, give yourself 400. You'll select your parts. Doing that will also make their keys visible on the timeline. And then you'll select all of the keys on the timeline. And you can do that with the window selection, just like you do with the objects on screen. And you'll stretch the left side of the black bar that you see all the way to the right. And then you'll move the entire group. Again, you'll just be moving the black bar back to the left to fill in the gaps. And then to slow the animation down and give it more time, we stretch the right side of the black bar. That takes care of the motion setup or the animation setup. We're getting closer to a final product here. We're going to look at the overall appearance. And that does involve some render setup. And it doesn't matter what frame you're sitting on for this next step. So you can set it back to frame 0 if you want. The slider bar, if it's out in the middle, that part, it doesn't matter. So what you want to do, once you set your motion and you're happy with it, is just run a test render. So I'm going to go back to the render setup now. We're still using the art renderer. We want to make sure that on the Common tab, our time output is set to single. We just want to render one frame. We don't want it to take us very long at all, and look at its overall appearance. We can also set our output size here, and right now I'm going with an output size of 640 by 480. The area that we're rendering is the view, so we'll leave that alone. And then we'll hit the render button. Okay, so here's what video would look like if we were to do all frames. And the reason we're testing is so we can make sure that we're happy with the appearance. If you look at this first frame here, the steel looks very grainy and noisy. You may not be happy with the background. We can change the background color. That will have an effect as well. But right now, what I'm noticing the most is how noisy or unclear that all the materials look. And that is because of the art renderer. So what we're going to do to quickly clean up our quality here, as a render setup for a moment, is we're going to run the scene converter. You'll find that on the rendering menu right here. And what we're going to do is convert the scene so that the materials are compatible with one of the other renderers. The one that I like to use is the Arnold renderer, and there is an out-of-box preset. So I'm just going to switch to that and convert the scene. It'll just take a few moments, and we'll close the scene converter. You won't see anything change yet. This is our previous rendering that we did, and I want to compare it to the converted scene. So in the render window, I'm going to clone this window. That just makes a copy of it. So that way I can run a new render, and then I can compare it to the previous render. And let that render. And here's the reason I like to run the scene converter and just convert it to the Arnold renderer. If you look over on the right, this is the art renderer. The result was noisy, a little unclear, things don't look sharp. After converting to the Arnold renderer, look at the difference. It's like night and day, and all we had to do was run the scene converter. So this is now closer to the result we're going to get. We don't want to render all of the frames yet because that would take too long. We'll save that toward the end. But I like what I see here. Now, if you do want to adjust the background color, you can do that as well. So again, I'll keep this window open. To adjust the background color, you'll find that in the rendering menu as well, under environment. So right now, just have a gray background. And, for example, if I wanted this to be a solid white background, I'll just change it there. And then render this window again. And so now we've got a white background. Of course, we can't see the bolts, but it did have an effect on the overall look just by changing the background color. We're not dealing with any lights right now. We're not using a camera. We're keeping this very basic. Just by doing some very simple changes, we can still get a good result. So that's a little too bright. So I'm not going to go with a background that's solid white. And so what I'm going to do is just undo back to the gray background and go with that for the rest of the example. You could spend lots of time with backgrounds and some of the other lighting settings on the environment dialog. We're just using global lighting, and right now I've got it set to white. But it keeps it very simple if we just work with the background color. All right, and that's all it takes for our render setup. After you run the scene converter, when you go back into render setup, your renderer will be set to Arnold, but all your other settings will be the same as they were. So we're still set to single output. Our view is still set, our size, nothing's changed there. The only thing that's been changed is the renderer. Okay, quick review. If you see the grainy appearance in your test renders, then make sure you use the scene converter with the Arnold preset. That will take care of that. And your final result is liable to be a lot sharper and more clear than before. While you're testing, make sure that your output is set to single. And if you need to adjust the background color, then you'll do that from the environment settings in the rendering menu. And lastly, I'm not going over it today, but at the very end, if you'd like to establish a camera, then you can do that just by pressing Control-C on the keyboard, and that will create a camera from the current viewpoint in your scene. And that's another quick way to eliminate additional steps when you're setting up using an actual camera. I've covered cameras in a few other webcasts that I've done on 3ds Max, and you can watch any one of those to get the details regarding that. This way is just a very quick setup, and we can still use default settings without having to know how to work with the exposure and things like that. To illustrate that, though, I could do that from this view right here. If I wanted to set a camera so it's recorded in the scene, I'm just going to press Control-C. And now if you look right here, we are now in a camera view. The reason we don't need to do this at the moment is because when we render, the scene looks exactly the same because we're using out-of-box settings. We're still not using any lights. We don't have a full environment set up. There's no building in the background or anything like that. So you can establish a camera if you want, but it may not be necessary. Okay, now here's a comparison side by side, just so you can see the difference. When we did our first render with the art renderer, the difference is the noise and the clarity. When you use the scene converter with the Arnold preset, you'll get a result that looks more like the one on the right. And we really didn't have to do any other setup work. All we have to do is run the scene converter. Now that the render setup is complete, we're happy with the quality, we can proceed to produce the video. So we're going to go back into render setup, and we're still on the common tab. We're going to change to the active time segment, which means when we actually start rendering here, every single frame will get rendered. And it can be time consuming depending on how long each single render takes, from a few seconds to a few minutes, or even more. So we do want to try and keep the total time involved as short as possible. So I like to set up assembly sequences and get it to a point that the people that I'm sharing it with can live with. And I think that's important because we're not producing major CGI effects here, but we want to give them something that is clear. It still looks good, but try and limit it to, what they can be satisfied with. That way it doesn't take very long to produce it. So, but we will switch to active time segment. This would be a good time to settle on the final output size. I've been using 640 by 480, and here's what size it would be. If you want a larger size, you would choose that now. So your final video, maybe it's going to be on a big screen, so you may want to use something at least 1280 by 720 or larger, depending on the type of monitor that it's going to be shown on. Keep in mind, though, the larger the output size, the longer each frame will take to render. So I would stick with that. For this example, anyway, I'm going to stick with 640 by 480. And then I'll need to scroll down in the render setup until I get to render output so I can save the file and then give it a storage location. By default, that storage location is going to be in a folder called Render Output, which will be one of the folders in the 3ds Max project. So you'll choose a folder location. Now, I've already created a few examples here. Name your file here. And for your file format, you'll choose AVI file. AVI is the video format that you can produce in Max. You can also produce individual image files of each frame and then stitch them together in a third-party program if you want. For now, I'm just going to stick with AVI. Your setup is over here, so you can control the quality of the final AVI. There will be some options for the compressor, depending on what's installed on your workstation, but you will at least have Microsoft Video 1, the DV encoder, and maybe an Intel one. Those all are out of box. I'm just going to go with Microsoft Video 1. It has always done well for these types of files. And the setup here to work with your compression quality. I usually push it all the way to 100% when I'm doing these. And the results are good, and you don't sacrifice a lot of time producing the file. And then we'll save that. Go ahead and give it a name. So once you configure your file settings, you'll hit the render button, and then the rendering will start. You might even hear the fan on your workstation kick in at some point, just depending on the magnitude of your animation. Now, I am not going to click the render button here because that will tie up my workstation for, say, 3 minutes or something like that. I went ahead and produced these ahead of time. Once you have that AVI file, you can view it in Windows Explorer. So here's the one I did from the art renderer. This is 640 by 480. And as you can see, it looks like it's snowing. And that's due to the fact that all we did was use that render. We didn't do any other settings. Here's the one from the Arnold renderer. And you can see it is not snowing in this version of it. It's a lot more clear, a lot more presentable. And it also didn't take any longer to produce the entire render. Each one was between 3 and 5 minutes, to manage that, total production time. Let's review those settings. Again, side by side, those are the two videos I just played back. The main difference here is I rely on the scene converter, and that gets rid of that snow effect. I'm not sure what else to call that, but that's what it looks like to me. Very jittery and noisy. So our settings look like this, again, in the render setup. When you're ready to produce the animation as your video, you'll change your time output to active time segment. You'll enable the render output so you can save the file. And your default file location will be in the folder called Render Output, which is a default Max folder. Every project has one, and it'll default to that, but you can save the AVI file wherever you want. From there, you can take the AVI file into another product if you needed to further compress it, reduce the file size, or you're doing any post-production. Also, I want to mention that there is a tool that comes with Max, so you can play back the file from inside of Max. And this works with images as well. It's called the RAM player. The RAM player is in the rendering menu. And if you had produced your sequence as individual images, you can load those in and look at it as a video file before you produce the video. It also works with the AVIs. So on channel A here, I'm just going to open it and open one of the AVI files. If it were images, I would just select the first image in the sequence, and the rest of them would get loaded. This tool, you can do some comparisons or at least check it before producing the final video. It does take a few moments to load because it loads each frame. Once it is loaded, we can play it back from here. But this is going to be the rendered version of what you've done on the timeline. So it's a great tool so you can review the results before spending too much time waiting for rendering to complete. If you like what you see, then you can finalize it out to the AVI file. Now, when you exit the RAM player, what you've loaded will be unloaded, which is okay. So remember the RAM player, you can use that as an extra tool to help during your final testing. And that's the end of the presentation. Now for some tips. So when you're linking your CAD files, just remember to use the select layers to include, so you can leave behind everything that is not important to your animation. You also want to hide everything else that doesn't need to be part of the animation. When you're first assigning materials, make sure you use the art renderer. It's easier for the application of the materials. But as you get closer to being finished, remember to use the scene converter to switch the materials to the Arnold renderer. This step is going to produce better quality images and videos with very little extra work. Set up your animation using the timeline. Make sure you use the auto key and move the components accordingly. Also, remember to rely on the playback tools and the slider bar to test along the way. So you want to, move a component or maybe two, test those, make sure they move the way you want before you move on. Once you're happy with that playback, then you're ready to produce your video. I'd like to mention our resources that you can take advantage of for self-help. On our YouTube page, you'll find the recordings for all our previous webcasts. This one will be online shortly. Our recorded webcasts are also available on our website. Plus, we have plenty of articles on our blog at hagerman.com, and we have content just for our customers on the Hub. I'd like to thank everyone for attending today. I hope you find this useful.